All right, this is section 3.4. We're talking about the composition of functions. But first we're going to be talking about the algebraic operation of functions. So if we have two functions, f of x and g of x, and their outputs are real numbers, so they're not imaginary, we define new function as f plus g, f minus g, f times g, and f divided by g by these relations. Okay, so if you've got setups like this right here, f plus g of x, well, really you're just going to add the two functions together. If you have f minus g of x, well, really you're just going to subtract the two functions from each other. If you have f times g of x, then just multiply the two functions together. If you have f divided by g of x, then just divide the function on top by the function on bottom, and make sure that the function on bottom is not equal to 0, or exclude values that would make it equal to 0. Otherwise, the bottom would be 0, which means the entire fraction would be undefined. So let's look at this. We have two functions. F of x is x squared plus 2x, and g of x is 6 minus x squared. So we're going to find f plus g, f minus g, f times g, and f divided by g. So f plus g, we're just going to take this function right here, f of x plus g of x. Now with addition, I can drop the brackets and just have this right here. So I have 2x squared, I'm just combining these two, plus 2x plus 6. And actually, sorry, this one is a positive, this one's a negative. They actually cancel out. And so what I have is this right here. So f plus g is equal to 2x plus 6. Now let's look at f minus g. So I'm going to change this to subtraction. Okay, now with this, what I have to do is distribute that negative to that 6 and to the negative x squared, which will become a positive x squared. Okay, now I have two of these. They don't cancel out, so I have 2x squared plus 2x minus 6. And that would be my answer for f minus g. Okay, now let's look at f times g. Okay, so times. So I need to use the distributive property, or you can use the full property here, either one. So, but I'm going to take x squared, multiply it times that 6, multiply it by that negative x squared. So I'm going to get 6x squared minus, well, when I have exponents that are multiplying together, you add them. So this will be x to the 4th. And then I'm going to take 2x, multiply times this 6, multiply times negative x squared. That would give me plus 12x minus 2x, and this is raised to 1. This is a 2, so 1 plus 2, that would be 3. Then I just really just need to put it in order. Negative x raised to the 4th minus 2x cubed plus 6x squared plus 12x. And that's the function when you take f times g. Now let's look at f divided by g. So we're going to take the function f, so x squared plus 2x divided by g, which is 6 minus x squared. Now it doesn't look like I can cancel anything out, so that's going to be my final answer right there. Okay, and let's do the same thing. We'll look at 2x squared plus 4x. For f and for g, it'll be 1 over 2x, and we're going to find f plus g, f minus g, f times g, and f divided by g. So f plus g, That would be 2x squared plus 4x plus 1 over 2x. So we'll have 2x squared plus 4x plus 1 over 2x. And that's going to be my final answer for f plus g. Let's look at minus. Okay, so this is going to be 2x squared plus 4x minus 1 over 2x. And that'll be my final answer for f minus g. Okay, if we look at times. Okay, I'm going to take this 2x squared, multiply it times this right here. So I'm going to get 2x squared over 2x, and then take this 4x times this 1 over 2x, plus 4x over 2x. Now notice the first one, the 2's cancel out, and I can cancel out one of the x's, left with 1 up here. Here the x's cancel out. I can take out a 2, left with a 2 here. So my final answer would be x plus 2 for f times g. Now let's look at f divided by g. So 2x squared plus 4x, all divided by 1 over 2x. So now this is going to be 2x squared plus 4x over 1 times 2x over 1. So I'm going to distribute this 2x to both the 4x and to this 2x squared. So what we're going to get is 4x cubed plus 8x squared. And that will be f divided by g. Okay, last one we'll look at. For f, it will be 3x squared, and for g, it will be the square root of x minus 5. We're going to look at x plus g, or sorry, f plus g, f minus g, f times g, and f divided by g. So f plus g, that would be 3x squared plus square root of, x minus 5. So that would be 3x squared plus the square root of x minus 5. And that would be it for f plus g. Okay, if we change this to subtraction, okay, what we would get is 3x squared minus the square root of x minus 5. And that'd be it for that one. If we look at f times g, what we would have is 3x squared times the square root of x minus 5, and that would be it for this one right here. Okay, now let's look at 3x squared divided by the square root of x minus 5. Now I can't leave a square root in the denominator, so what I need to do is rationalize. So I'm going to multiply the radical times the top and the bottom. So we'll have 3x squared times the square root of x minus 5. And then a radical times a radical really just cancels each other out. I'm left with what's on the bottom. So x minus 5. Now, remember, you don't want the bottom to be 0. And so we set what the bottom is equal to what we don't want it to be. So we can't have 5 or x being equal to 5. And also we've got a square root on top. So what's inside needs to be greater than or equal to 0. So x needs to be greater than or equal to 5. But down here, we said that x can't be equal to 5. So all the numbers that will work for this particular fraction would be combining what we know here and what we know here is x has got to be greater than 5. Those are the numbers that will work for this fraction right here. Now we could go back to this one and say, okay, well, we're going to set this thing equal to what we don't want it to be. So x cannot be 6. Then I'm going to square root that. So x cannot be the square root of 6. Now let's look at the composition of functions. So basically what we're doing is we're putting one function into another function every time we see an x value within that function. So when the output of one function is used as the input of another, when we put one function into the other one, we call the entire operation a composition of functions. So for any input x and functions f and g, this action defines a composition function. Now you can write it as two ways. You read this as f of g of x. And what that really means is you're going to put the second function here into the first one like you see here. So you read this one as f of g of x, the same way you read this one right here. Okay, the domain of the composition function f of g is all x such that x is in the domain of g and g of x is in the domain of f. Okay, it's important to realize that the product of functions f times g is not the same as the function composition f of g of x. Okay, so this is not true. You can't just say, okay, well, I'm just going to multiply these two functions together. That's not the same thing. What you're doing is you're taking one function and you're plugging it in to another function. Okay, and also, you can't switch them around. Like I'm going to plug f of x into g. That's not the same thing as saying I'm going to plug g into f of x. So they're not commutative. I mean, you can't switch them around and they be the same thing. You're going to get different functions when you do that. Now we're going to look at three types of ways to evaluate composition functions: using tables, using graphs, and using formulas. So first one, we'll look at using tables to evaluate composite functions. So when working with functions given as tables, we read input and output values from the table's entries and always work from the inside to the outside. We evaluate the inside function first, and then we use the output of the inside function as the input of the outside function. If that's very confusing, just hang on. Okay, so we're going to use the table to evaluate the composition function of f of g of 3 and g of f of 3. Okay, so if you look at f of x, inside here is, well, we have the x value, right? So right now, I'm working for this one right here. I'm going to look at the very inside, which is 3. That is the x value for g. So we're going to go to 3, and then we're going to go to g of x, which is 2. Okay, so now what we've done is we've turned f of g of 3, let me write that a little better, a lot better. F of g of 3 is now f of 2. So we go back and we say, okay, well, this is right here is my x value. So I'm going to go to 2, and then I'm going to go to f. So this is equal to 8.